Okay, let's get into this section on AWS Lambda. And Lambda is kind of a catch-all for doing a whole bunch of stuff using a programming language like Java, Python, Node.js. And with Lambda, we can pretty much build, if we wanted to and we don't, any of these AWS applications that we see, but hand code it. So obviously with Lambda, there's a ton of flexibility. Lambda's advertised as a serverless architecture that only utilizes the resources that you need, so you're not overpaying for resources you're not utilizing. To me, that's not the big deal about Lambda. In a production environment where you have massive scale, that's going to be really important because you don't want to pay for a chunk of service, use half of it, but still get charged for the whole chunk. So you hear a lot about these microservices managed by AWS Lambda, which is great. For us, that portion of Lambda is not a big deal. So that's kind of the 10,000 foot view. But let's get into specifically what IoT with AWS Lambda is. So we got our MQTT protocol sending us these JSON packets to trigger a rule, and it allows us to process incoming messages, then call another AWS service, or if we want to, a third-party service, which we haven't done yet, via this Lambda service. Now, here's a couple diagrams below that kind of give you an idea. Here we have our device going to the AWS IoT gateway, to Lambda, to DynamoDB. This could be good for a filtering algorithm. We're not going to do this. This is kind of what we're going to start with, but backwards. We're going to send that sensor data coming to our IoT gateway to an AWS Lambda function, which is going to send it over to CloudWatch log. Now, is that super useful? No, not really. I mean, I'd rather store it in a Dynamo database, which we've already done, or store it in S3, filter it coming in through Lambda, or filter it going out through Lambda. But CloudWatch, this is just an easy example to get you familiar with how this works. So this is how I want to introduce it, by this simple example, and then later on, after you understand everything in the course and have time to develop more of a filtering and transform algorithm, getting to some cooler features of Lambda, of things we can do in programming. But this can get pretty advanced because we're going to be hand coding these Lambda functions. So as far as exploring AWS IoT, I want to keep it fairly simple because we can get really complicated with this stuff and far exceed the boundaries of what we want to cover in the course. But let's start now with this simple CloudWatch logging example. Then later on, I'll add some more complicated examples that are actually going to be used for filtering and transforming. Okay, welcome back. So now we're going to do our Lambda function to create our CloudWatch log action. So to do this, we're back in our control panel here for IoT, doing our rules and actions. So we're going to start out creating a new action. And we can name this my Lambda action or whatever you like. And what is this going to be? It's going to be our incoming JSON packet data. Instead of being sent to previously, as we've done, to S3 or DynamoDB, it's going to be sent to our CloudWatch logs. And we'll specify in our Node.js code how it's going to be labeled and enumerated into our CloudWatch logs. So we'll just say into CloudWatch. And we'll use the same kind of query statement we used before. We'll have the whole JSON packet delivered, and the topic filter is going to be that my topic get payload, or whatever your topic filter is. We're not going to have any conditions at this step, so let's add the action for Lambda. So we're going to go up here and invoke Lambda function when we pass our message data. So let's create this, or configure it. Now, this is kind of that weird thing like we did with SNS where we have to work backwards because Amazon AWS IoT hasn't designed this super well. So we can't actually make a Lambda function from this screen. We can't do that. So we have to go back to the Lambda application itself and create a new Lambda function and put our code in from there. So let's just open another screen. I'm going to right click this over here and we're going to go to Lambda, which I already have enumerated here, and I'm going to create a new function. So let's go ahead and do that. So I already have my old function there. I'm going to create a new one. And we're going to start off with a blueprint. So it's going to have a lot of the prerequisites already done for us. And the blueprint we can start off with, of course, is just a hello world, which is like a blank blueprint with nothing on there. And it's using Node.js 6.1, which is what we want to do. That's the most recent version. So let's configure this. And now we can call it my Lambda function or func, whatever. Choose an existing role. So I'm going to go ahead and create a role from template. We just have to put into permissions from the template of the roles we need to use, and you'll see that in a second. And our Lambda role. And here's our policy templates now we can add to our role. So it's going to give us a bunch of ones coming from AWS IoT. All we need for the CloudWatch logs is this CloudFormation stack. because it's going to be able to write automatically. And now here's where we're going to put our code. So this is kind of the generic code that's already in here. And our code's going to look very much just like this generic code, except instead of having 3 events coming in, we have 4. Remember, we have temperature, humidity, time, and device ID. Go over here to gedit, copy my code, and we're just going to paste that in here. And I'll explain a little bit of it. Okay, it's not letting me paste that in there yet. I have to actually create it first and then go back and paste it. All right, so we'll be able to configure that in just a second. So now we're going to add our triggering action. Our triggering action, of course, is going to be AWS IoT. And then to configure it is where we're going to add that additional code. So we'll do that down here. We're not going to use the IoT button. We'll use a custom IoT. So we're not using that Amazon IoT button you can use. We're going to create a new rule, and I'll say our Lambda rule. I want to fill that out. And for whatever reason, I have to enter that query statement all over here again. So I'll just do that real quick. It shouldn't ask me for this because I already put in the first part, but from creating a Lambda rule from this screen, it doesn't know about that. So let's go ahead and add that. All right, now that that's added, we can go back to where we were before, refresh this, and select it. There it is, my Lambda function add action. Good, so everything's pretty much done here, except if you remember, we don't have any code in our Lambda function. So I had to, again, it's kind of quirky, I had to create it, and now we want to enter that code to what we have over here, which is specific information about our 4 events that are in that JSON packet. So let's copy that again, and from here go back to Lambda, and then we'll dig into the action we just created, and then we can edit our code. So this is the one we just created. Let's go into this, and then we'll see what our generic code looks like. And you'll see we have AWS IoT activating CloudFormation and CloudWatch logs. Now we can activate our code. So let's paste our new code in here. And you see, now I'll explain the code a little bit. We're using strict, which is well-known JavaScript here to make sure that you're using the proper conventions. We've got our export handler function here. Console log, just output to the console log. It's not telling you where it's outputting, but it's outputting to those CloudWatch logs by default. So we're just calling our output temperature, humidity, time, and device. That's not important what we call it over here. This is just variables that are going to be printed in the cloud logs. These are the ones that have to match. So these class members here have to be spelled correctly to what we have in that Mongoose or that Xerinth or whatever sketch you're using. These names have to match as class members. Temperature, humidity, time, and device ID. So now we can resave this. And we should be go. Now we have the updated code and we don't need to change any of this stuff. So we're good to go with this. So let's go back to the AWS IoT console. Make sure our Lambda action is enabled. Now we can go to test it. So now let's subscribe to that get payload. There it is. Subscribe to this. And I'll just send it a few through our ESP device or whatever you're using. Let's send a few data packets so we can watch it in Cloud Log. And I'll send it one more. All right, there we go. We got those all in Cloud Log. So the last thing we have to do is open another console and check out that we actually have created that in Cloud Log from our Lambda function we just coded. So we'll go to CloudWatch. So CloudWatch under Logs. And here's the most recent one is my Lambda function. That's what we're looking for. That's it. And then when we open that up, there we go. You'll see that I have those 3 readings, those only 3. Now there's a lot of ancillary junk here we don't want, but you see the output temp humidity, those are those local variables that got named, are correctly assigned to the incoming variables from our JSON packet. So that's all correct. So that's a real basic Lambda function, nothing very excited, but something to get started with. And I hope to add more that's going to be more useful for transforming and cleaning our data than just printing to CloudWatch logs. Again, and this is inferior to going to S3 or going to DynamoDB. I would rather use these Lambda functions to do some filtering, so that's what I'll probably add really soon. Okay, welcome to this where I go over an advanced Lambda example. And before I go into programming the Lambda example and sending data payloads through AWS IoT Core and show you how they work with MQTT publish and subscribe topics, I want to give a shameless plug to my new course. And the reason this is an apropos point in the course to do that is because I cover Lambda a lot more extensively in this course. So when we talk about serverless design model for IoT, we're kind of talking about the same 4 or 5 services whenever you hear about AWS serverless, and those being API Gateway, Lambda, S3, DynamoDB, and in our case, AWS IoT Core as well. And as far as that goes, Lambda is the most important component of everything in serverless because within Lambda, we can do data transforms, data enhancements, data filtering, all kinds of data manipulation and sending datas and dispatching datas through the AWS SDK in Lambda or Roboto 3 and Python in Lambda. We can send it to all these different AWS services. So Lambda is incredibly powerful. So if you want to go further in AWS IoT serverless design and especially covering Lambda a lot more extensively, then I'd recommend my new course. But let's go ahead in this course and go over a relevant IoT example in Node.js and Lambda. Okay, so let's look at one of these more advanced Lambda function that actually does something useful. Because let's be honest, in the previous example, taking something from IoT Core, throwing it through Lambda, and just giving some explicit information on the incoming payload to CloudWatch isn't really all that exciting. And by default, CloudWatch is enabled anyways. I didn't tell you that, but that's the case. So we'll create a new action using Lambda that's going to be something more useful and more advanced, and I'm guessing something you haven't seen before. So let's go ahead to action and rules, and we'll go ahead and create a new rule. And I'll call this one my IoT publisher. So I'll just say IoT pub. And our description will be publish our IoT payload to another device using that MQTT subscription topic on device published from Lambda on the cloud. So I think that's pretty cool. And despite this terrible spelling, I think you get the idea. Let's go ahead and change that to what we've been using for our device in that single page sketch, and it was just out topic. That's the topic coming out of our ESP device or Raspberry and coming into the MQTT broker on the AWS cloud. And let's go ahead and add this action. So again, this is going to be obviously a Lambda action. So it's going to send the payload to the Lambda function. It says message, but it's mainly our event payload. So go ahead and click that and configure the action. And I don't have a Lambda function made. So again, before I can do this, I'm going to have to make my Lambda function next. So again, I usually just duplicate this tab, go over here, back over here, and I'm going to create the new Lambda function. And this is where all the magic takes place. So let's create the Lambda function, and we'll call it an IoT publisher. Call it something a little bit different than our action, but we can actually call it the exact same thing. It doesn't matter. I'm going to author it from scratch. And now we're up to Node.js 12, not 6. So it's backwards compatible, so that's the good news. And I'm going to add additional resources to this execution rule, but for now, I'm just going to leave it like this for permission. So again, this is execution rule that's automatically going to be created. It's going to allow Lambda to execute itself. When we add it in from IoT Core, it's going to add IoT Core as a trigger. I know in the last example I did it differently. I added the trigger on Lambda itself, but we can just do it directly from IoT Core by default. So just leave it as this and go ahead and create the function. Okay, so it created the function successfully. Great. Now I'll just paste my code in here, replace the default code on the index handler, and paste in my own index.js. And of course you can't do it that way because it's a Linux system. So anyways, here's my code. And I'm doing it in US East 1. You can use this whatever region we want. Now, you guys probably know this, but I didn't give you an example of this. In Node, when I say import require AWS SDK, what the AWS SDK is, the development kit, is it allows access of all these AWS micro functions. So if I want to send a message to SNS from Lambda, I can bring it in by this AWS SDK and just create an SNS object. And I can do that same thing pretty much for any service I want in AWS. So if I say, hey, temperature is greater than 77, do a simple notification or do an SMS to your phone and send me an alert. We've already shown how to do that earlier in the course from the IoT Core console, but just so you know, we can hand code that here in Lambda. Of course, the disadvantage of Lambda is everything has to be hand coded. And if I want to do this in Python, again, I can just bring, instead of the AWS SDK, I would bring in what's called Roboto 3. And if you're a Python guy, you can do it that way. But here I'm using Node.js. Okay, so what are we going to do? We're going to bring in the event object. And again, this is the event object coming from AWS IoT Core. So it always comes in as event.class members. So we got our temperature, our humidity, our time, and our device ID, just like I used in the last example. If you have different parameters from your incoming payload from your device, I just wanted you to let you know that this is how it works. It would be just this dot extension for each item. And you'll see this later when we talk about shadow topics. Anyways, we're not going to mess with the individual items because I'm just going to bring in the entire event. So think of this entire event as just a payload coming in from IoT Core, which we're going to connect next. Now, we can have whatever topic we want, but we've been using in-topic. Now, here's a shadow topic, and I'm going to explain all about shadow topics later in the course, as I did a new lecture on that this year because people were interested in it. So this is a really good shadow topic to use, shadow update, because it'll keep the current state or the last known good state on the device. But for this example, I'm just going to keep it simple. I'm going to say in topic, which again, in topic's what's being subscribed to on our device. So by using in topic, I can send our payload or an altered payload to the same device or to a different device. So I'm going to send it to a different device. So if we have in topic coming in from one device, say we have 10 different devices, I'm going to send it out to thing 7. This could be device 7. So I'm just going to actually, for this example, and you're going to see how I'm going to do this later, copy this, and we'll have our parameter package filled out as Control V, as in topic from thing 7. Again, that's completely arbitrary. You can call yours whatever you want. Just remember, say you program this with that single page application sketch in Arduino, the in topic is what I'm subscribing to on the device. So I would need in topic underscore device 7 if this was my 7th device and I wanted that packet from another device. So as you remember our sketch, and if you're using Mongoose or Xeroth, it would be the same thing. And this is where you'd want your topic. And you could probably figure that out yourself. Anyways, so that's going to be how we fill out the parameters for our object here. We have our topic. We're going to bring over our entire event from one of our devices and send it to another device. And we'll keep our quality of service as the lowest priority here as 0. That's fine. That makes everything easier. Now, we instantiated our IoT data object. And again, that's held over here in AWS IoT data. And instantiate that object and publish it. And if we get an error on that async event, it's going to just say, hey, we got an error on our payload here. We're stringifying our payload. Otherwise, if the payload works out and it resolves, we're going to just console log success. But where the real magic takes place is right here. When we resolve our promise, it publishes right here our parameters to this topic. And I'm going to show you how this works in a second here. So go ahead and save this. And let's go ahead and test it, and then we're going to send it a live payload. But before we can test it, let's go ahead and finish our IoT action. So let's go ahead and select it. So I'm going to need to refresh this because this has the old stale data before we created that Lambda function. So go ahead and hit refresh. And now we can look for that IoT publish function. And there it is, IoT publisher. Go ahead and add that action. And we're good to go. We're not going to make any tags or anything. Go ahead and create your rule. And make sure your rule is active. That should be my only active rule. When I'm not using these other things, I just go ahead and disable them. There's my new one, IoT Pub Action, and it's enabled by default. So that's awesome. So next what I'm going to do to test it is go ahead to a test event. And let's go ahead and subscribe to just a random topic. So I'm going to say topic, how about VVV? I'm going to go ahead and subscribe to this, and you're going to see why. So I'm going to subscribe to this, come back here to IoT Publisher, and now let's change this to VVV. And again, we're just testing it in the console. And of course, we have to save that, and now I'm going to set up a test event. So go to test, and I'll call this T1. That's my typical name I like to use for a test event. And we'll fill in our data payload. So I'm just going to use the last data payload from the last lecture, and here it is right here. Just an arbitrary payload that has everything we need on it. So I'm going to stick it here. Just make sure it's in JSON format. And it's going to have everything we're looking for. So temperature, humidity, time, and I just said device 4. But since we're publishing on device 7, I should call this device 7. So I'm going to hit device 7, Go ahead and create that. And now we can go ahead and test it. So go ahead and hit test. And if you notice it got this response, what could be the reason for that? Well, as I said, we have to assign additional permissions from our role. So now that we added this Lambda function into IoT, if we come back here, we know if I refresh this page, you'll see that I have added in a trigger from IoT, so I can IoT publish to Lambda. Lambda has that innate role where it can execute itself, but the problem is it doesn't have an IoT publish role. So I have to add that IoT publish role. So go ahead to permissions. So let's go over to our role right here. I'm just going to open a new tab. And in IAM, all I'm going to do is give it IoT all access. Easy enough. So now my Lambda function has the right to publish and do whatever it needs. It can trim a publish package. There's a bunch of things it can do. So again, currently it just has this execution role. We'll add an IoT all access. Keep it easy. It's already a predefined manage role, and they're all down here. IoT full access, right there. So now I'm going to allow Lambda IoT full access. So go ahead and attach this policy. All right, so now we have our execution role where it can execute itself and AWS IoT full access. Go back to Lambda and let's do that same thing again. Want to get out of the permissions tab, go ahead and test that. It's got that same data package in it. And now our results succeeded. It's still going to give you a null response, but now it's succeeded, and let's go make sure. And indeed, under that arbitrary subscription topic, VVV, we've just published our data package. Okay, so that's awesome. We've done that. But let's go ahead and open a new console and duplicate this. And now I want to publish to this topic. So I'm going to publish to, what was our incoming topic? It was out topic, remember? So in our IoT action, out topic was our incoming topic. To out topic, and you'll see over here in topic CCC that message just came through. So, and that's our subscription topic on this AWS IoT console. But remember, this really is supposed to represent another device. So if I had another device that was subscribing to topic CCC, you would get this message on the device. So you can see from this example how powerful using an IoT publisher or using AWS SDK to invoke different microservices can be. Okay, let's move on. Okay, as promised, I told you I would give you another one of those IoT payload publishing generators. And instead of that one that worked from a bash script, this one works easily right from Lambda. So here it is. I already set it up. You're just going to create a new Lambda function, make sure the language is Python. I used the latest version, even though when I found this on AWS samples, I think it was a couple years old, so it was like probably Python 3.6. Now I'm using 3.8. But basically, you can kind of see what it does. It creates 4 fake devices, and then for each device, it just generates random data to some variables. I think there's a temperature, humidity, flow, sound. I think maybe wind speed's also included. And it also has the ability to send this out to different topics based on different contingencies. I just changed the topic to XXX just to make it super easy to test with. So I set up a test event, this T1. It doesn't really matter what your test event looks like. My test event is just a standard key value, key value, key value. And that's because it doesn't take the event object into consideration when it runs this Lambda. All it's used for to hit that test event is to kick the Lambda off. And it'll run for the complete execution of the Lambda that you set. This one I set for like 3 seconds. That was the default, I think. So for all 3 seconds, depending on how long you make it sleep between iterations, it's just going to send data packages. So let's go over here to the MQTT test client. I put in XXX. I'll go ahead and subscribe to that. So I'm just going to run this, and then hopefully at the same time here, it's going to start publishing data. Again, I've already deployed it. And the other thing you need to do is, if you just use the basic Lambda execution rule, it's not going to work for obvious reasons. That just gives it permission to run itself. So you have to go over to configuration, permissions, pull up your policy, and add in the ability to IoT publish. You can say IoT all access. I used IoT just ability to publish from Lambda. And that's done in IAM. And I've already showed you how to do that. So just so you know, if it doesn't show up in your MQTT test client, that's the reason. All right, let's go back here to the code, and we're all set to go over here. That's the last execution, so I kick it off by hitting test. by just a generic test event. Come over here, and if everything works out, it's going to start publishing data. There it goes. It publishes like one every half second or something. That's just because that's how the iteration loop timing is set, and you can adjust that. But I think it's a really handy script. It's not quite as handy as that bash script, but this is an easy example to show you how to do a IoT data publisher from Lambda. So hopefully that works, and I'll put a link to this on my GitHub. And again, I got this off AWS samples.